In the last episode, we covered how information is transferred in a connection between a Bluetooth low-energy peripheral and a central. Now, looking at this hierarchy of protocols, controlling the radio, formatting the information into packets, creating profiles and services and characteristics and descriptors, you might be worried about the amount of code you have to write to make all this happen. Well, don't worry, Maxim has you covered. All of the programming to run the radio and the protocol has already been written, tested, and vetted by Maxim or one of its technology partners. All you do is write the application and pull the various BLE levers using API calls. Oh, wait, what's an API? An API is an Applications Programming Interface. It's the way low-level services interface to higher-level code. Now, the good thing about an API is you can write your application without even thinking about how the underlying hardware or even the network interfaces actually work. All you know is that you want to get some information from there to here, and you write a call to an API with a request, and the transfer just happens. Now, if you decide later on you want to use a different radio or a different processor, no problem. The code that runs the radio or the processor's peripheral set, that all happens below the API layer, so you can write your application without knowing or caring what hardware platform is in use. Let's explore this a little bit. At the bottom of the stack is the radio hardware. Now, it contains the transmitter and receiver, which, when you think about it, are really just mechanisms that couple the air interface, the transmit-receive switch, perhaps a matching balun, certainly an antenna, to some hardware that exposes data to something. That hardware probably consists of a FIFO to manage inbound and outbound traffic, and a set of status flags and control bits in registers. And that's great. Radios have really come a long way since the days when they were just a dumb oscillator, tuner, and amplifier. But your application really doesn't even want to think about the radio, at least not much. It does have to be aware that it's in a Bluetooth application, and that means it has to understand concepts like advertising, connections, and sending and receiving data. But the application has bigger things to focus on than the nuts and bolts of how to talk to a radio. Well, the good news is that there is some pre-built software in the middle, a stack. The Bluetooth stack contains all of the mechanisms to implement the protocols that collectively are known as Bluetooth. It's all the stuff we've covered so far, and a lot more. But because Bluetooth is so complex and so intricately intertwined, the best solution is to use a stack built by experts. Now, the stack has to talk to the radio hardware to modulate Bluetooth-compliant signals onto the RF carrier, and it has to interface to the application to deliver the bits of information that the application demands. But there are a lot of different kinds of radio hardware out there, so do we have to have a different stack for every radio that some chip company dreams up? Well, the answer is no. The chip company writes a driver to connect the stack to the radio hardware. The driver software talks to the various register interfaces exposed by the radio hardware and handles any timing or data flow considerations that are unique to the radio. Then the driver exposes a standard interface defined by common specifications up to the Bluetooth stack. The stack can then use a standardized status and control mechanism to manage the radio hardware without actually knowing all the particulars of the hardware itself. You could say that the hardware is abstracted by the driver. So, the application talks to the Bluetooth stack, right? Well, not so fast. The stack itself exposes a lot of low-level concepts that the application really doesn't care much about. What you really want to expose to the application is more the concept of a channel or a port. You just dump data in and suck data out, rather than thinking about exactly what the source or destination of the data actually is. And that's the job of the API. The API remains constant regardless of the internal structure or operation of the stack. The API and the stack communicate over a standardized interface, and the API and the application talk over a published set of rules that are collectively called the API. The API exposes standard functions, and the application gets to send and receive data the way it wants. So that's the story. Your code talks to a simple, easy to understand API, and Maxim's API talks to the stack, which talks to Maxim's hardware interface layer, which talks to the radio hardware. You don't have to worry about timing or protocols or anything really. You only have to think about what your application is up to. Hey, Maxim is all in with Bluetooth Low Energy, and especially with Bluetooth 5. The combination of faster speeds, more robust channels, and ubiquity across devices of all types makes BLE something of a no-brainer for short-range wireless connectivity. So stay tuned. We can't wait to show you what's coming next.